Hi everyone, welcome to our video on limits at infinity. So the difference between the infinite limits meant that we could have answers that are infinity like these. Limits at infinity means our x is headed toward either positive or negative infinity, which will tell us the end behavior of the graph. So the far right of the graph or the left of the graph are the ends of it. All right, and we have certain rules here that we could follow. We could also, again, just kind of graph on our calculator to really verify. But if we have a polynomial, so this is our general form for a polynomial. Remember, a polynomial is just saying the x's have whole number powers. Okay, so whole number positive powers, so like 1, 2, 3, 4, 5, so on. And well, depending on the power, it tells us how we can break down our answer. So when we have the limits, as x goes to either positive or negative infinity of x to the n, our answer is infinity when n is even. Okay, and just real quick as a reference, so this is an example, x squared, that's even. Well, that is the graph of a parabola, and we would say, hey, those go up forever, so that's why that's infinity. Okay, so you could use a reference as well. When n is odd, you get two different answers. So as it goes to infinity, it is infinity. As it goes to negative infinity, it is negative infinity. And again, kind of as a reference, where n is odd would be like y equals x, which is this graph. And then there we can see it. So as x goes left forever, our y coordinate goes down forever. As x goes right forever, our y goes up forever. So we can even label these. This is saying as x goes to infinity, y is going to infinity. This one as x goes to the left forever, x goes to negative infinity, y is also going down forever. Whereas this is x goes to infinity, y is also going to infinity. So as x goes right forever, y goes up forever. And this one is left and up. So this means we have, let me just kind of put it a little down lower. X is going to negative infinity, so that's left forever, but y is still going up. Okay, so anyway, so that's a different notation that you could use on these as well. Okay, so another special rule is if you have 1 over x to the n, then it really just becomes 0. Okay, so what this is saying is 1 over a very large number goes to 0, and you might see it in a pattern like 1/10 is 0.1, 1/100th is 0.01, 1/1000th is 0.001, and you can start to see the pattern. Okay, so as this gets bigger, our decimal is getting a whole lot smaller. Okay, so that means as this gets really big, the decimal should be really small, which means it's very close to 0. Okay, and then our last rule, if we have a polynomial, then all we really care about is the leading term, so just the very first term, to figure out the answer. And then it goes back to these two rules. All right, so anyway, so let's break these down. Okay, so let's determine the following limits. So here we have the limit as x goes to infinity of 4x to the 7. And you could even, so this isn't really good math notation to plug infinity in. Infinity to the 7th would be considered to be infinity. And then 4 times infinity would be infinity. So that is one way you could break it down as well. This also is just following this rule here, number 2. As x goes to infinity, this is odd, it goes to infinity. And then the times 4 is still infinity. Anyway, and then with this one, just to show it, 4 times negative infinity to the 7. Well, negative to the 7 is still negative. However, infinity to the 7, we would still write as infinity. And then 4 times a negative infinity would stay negative infinity. Okay, so there's that. And just to show it, let's use the calculator. So those rules are nice, but you don't need them really too much if we've got this technology help. I'm just going to type in the 4x to the 7. So there's our graph. And I can zoom out as much as I want. It looks almost like a vertical line. But what's happening is, well, as it goes right, it's going up forever. That was that first answer, infinity. So as it goes right, it's going up forever. as it's going left, it goes down forever. Okay, so it's not going to turn around. We can see everything. Again, it looks pretty much like a vertical line when you zoom out that far, but it is going down forever on the left. It's going up forever on the right. Okay, anyway, so that's that. And you could do the same thing. Let's go ahead and plug that into this. Let me just delete this. So remember, they prefer x's. So 2x to the 4 plus 8x squared minus 1351. And then from there, we could see, zoom it out. Well, so there is, we can see the bottom of it. So it's like a parabola almost. So there's nothing else below. And then we can see, well, from the left. Okay, so from the left, it looks like going left, it's going up forever. From the right, as our x gets bigger, our y is getting bigger as well. Okay, so it's going up forever too. Okay, so that's that. So we know it's infinity. We know this one is infinity because it's, as this is saying, as x goes. So let's just make a kind of quick graph. So that it's looking at that portion right there for this problem. And again, we have a quick rule. We could really just look at just that and say the limit. So this would match. And then from there, you could plug the infinity in if you want to. And then we have infinity to the 4 is infinity times 2 would still be infinity. Okay, I would still double check the graph of it because you might say, hey, what if I plugged infinity from the start? Wouldn't I have infinity plus infinity? Or you might get a scenario, for instance, let me go ahead, like right here. So say you plugged in infinity into, actually, let's just do, say, a side one. So sorry. So I didn't type this in, but this is a mistake. So if you plug infinity into this, you might say, hey, infinity getting squared is still infinity. And then minus an infinity would be 0. But this is not how it would actually go. So this is the only thing we would really care about because this graph is a parabola. It looks something like this. So that means it should be going up to infinity for an answer. So to say infinity minus infinity is 0 is a mistake because this infinity is squared. So technically it's bigger, but we don't have a different symbol to say that it's bigger. So this is really just infinity. And that's where I would probably just say, hey, graph the whole thing anyway to really verify. So just to check, just to show it with the calculator, x squared minus x. You know, I said it's a parabola. There's the parabola that we can see. And then we can see, oh, from the right, it's going up forever. From the left, going up forever still. Okay, so that way you can still get your answer. Okay, anyway, so or if you're very comfortable with the rules that are right here, that's fine too. I would just say be extra careful because they don't take very long either way. Okay, so with this one, I'm just going to plug this guy into the calculator as well. So we've got -5, and if we, again, use x instead of the letter that they wrote, to the 9 plus 3x to the 4 minus 2x. And we see, well, it's pretty much a vertical line. Okay, so we don't see much going on with it. So kind of strange. So this is where the calculator maybe is not the best because I don't really see much happening with it. Well, this is where maybe we could change the graph settings. Okay, so you could try to see if changing the x step is worthwhile. Okay, I don't know if this is really worth it. Okay, so probably not. Okay, so this is where sometimes seeing the graph isn't the best. Okay, so it's kind of not showing me much. I want to make sure I'm going to get the right answer, and all I can see is really just a vertical line, and I don't know what's really going on. Okay, so that's where those rules may be a little bit more useful. So I said sometimes we're not needing them, but this problem is the same as really just looking at this portion only. Remember, these no longer matter. So it's just the biggest degree that's important to us. Just like in this example that I did down here, all that mattered was the first one to get our answer. Okay, and then this can help us because now we could say, hey, -5 times -infinity to the 9. Well, negative to the 9th would still be negative. We still have an infinity. So that would be -5 times -infinity. Okay, negative to the 9 is still negative, and then we don't really need a 9th power on the infinity. And then when we take -5 and multiply it by -infinity, we would get a positive infinity. Okay, so infinity is a weird idea. It's kind of absorbing numbers, okay, because it's so large, this 5 really doesn't matter to it. Okay, so that's what this one should be. Let's see if just graphing just the -5x to the 9 can show that a little better. I don't think it will. Okay, so it pretty much looks the same. Okay, so it's not helping too much in our problem. Okay, so that lets us know we probably need sometimes to rewrite this. I'm going to zoom in as far as I can to see if it looks anything less than a vertical. There we go. So zooming in might have helped. Okay, so from here, then we can see, oh, that's why it looks like a vertical bar. From the left, there it goes. It's going up to the left. Okay, so the -infinity. So there we go. So that's the better way to deal with it in the graph. So I was trying to zoom out too far. So just to know, hey, zoom in too. That could work. Okay, so play around with these. So notice the settings didn't really help me much. Instead, it was just zooming in. All right, well, that works. Okay, so that's good. So we verified it with the calculator eventually. All right, and then our limit here. Well, again, you can plug this in to our calculator and see how it goes. And you might not need my help too much if all it is just plugging in, right? So, but at least we can explain a little bit more with it. Okay, so I have 9 divided by x to the 4. And then minus, oops, that's not where the minus is. Let's move it again. Minus 5 divided by x squared. And then minus 12. Okay, so what this is saying is w goes to infinity, but I'm really using x. So as x goes to infinity, so that means as x goes as far right as possible, what's happening? Here's where I do want to zoom out. Okay, so as it goes far right, look at this. It looks like it's just staying at -12 the whole time. It's getting very close to it. And then at this point, it just changed to -12 because I think it's just rounding. Okay, so you can kind of see. Yeah, to the right, it looks like it's just -12 as far as I go to the right forever. Okay, so that's going to be looking like our answer. And the reason for that is, well, using our rule, right here, number 3, 1 over x to the n, if you plug an infinity in, is headed towards 0. So this portion became 0, minus 0, and then the minus 12 is just there still. So there we go. However, again, it might have helped to just go ahead and get the picture. It looks something like this, where that was at -12. And so it's saying, all right, as it goes right forever, it's staying at -12. So that's our answer. Okay, so that's dealing with these end behaviors. And finding the limit. Okay, so graphing tools are very helpful for us in these problems. All right, one other thing that's useful for us are certain rules where we have asymptotes and horizontal asymptotes instead of just vertical. So end behavior and really horizontal, let's just put that with it, horizontal asymptotes of rational functions. So we have 3 rules here where all we have to do is look at the degrees. So when we have p of x over q of x, so a smaller degree over a larger degree in this case, our limit as x goes to either positive or negative infinity is just 0. Okay, so this larger degree down below makes the limit go to 0. And then instantly we have y equals 0 is a horizontal asymptote. Our second case is when they are the same degree. So remember, the degree is just looking at the biggest power in your polynomial. Okay, so the degree, if they are the same, then all we do is take our leading coefficients and divide them, which means our y is those leading coefficients also divided as a horizontal asymptote. And then our last case, when we have p of x is larger, so the top one being a larger degree than the bottom, then our answer is still going to be infinity or negative infinity. We will not have a horizontal asymptote. Okay, we could also use a calculator. We could also do this type of division. It's all up to us. Okay, so let's show these different ways. Okay, so on this problem, oops, let me not write the limit. I don't need that actually. Okay, so on this, let me just mark and say, hey, these are the same degree. They're both degree 3. Okay, so these are both degree 3. Let me just mark it right here. So these are both degree 3. Because that's the highest power on them. Those are both degree polynomials. That means they're the same degree. And if they're the same degree, then our rule is just divide the leading coefficients. So this limit is equal to 3 over 15, which equals eventually 1/5 when we simplify. And so then that means we do have a horizontal asymptote. So if we have our value here, we're just following that number 2. Our horizontal asymptote is just make sure you put y in front of it first equals that 1/5. And there we go. Okay, and like always, we could check it. Let's go ahead and check this one. Okay, so we'll type all that in. So we have parenthesis 3x cubed minus 9x plus 1 divided by 15x cubed minus 22. Okay, and then I'm looking at, and we only use these rules, so these are special rules too on our page, only when we're looking at negative infinities and infinities. Oops, not that button. So that's what's important. So we have other strategies for other problems, so make sure we're not mixing them up. Okay, so these all go to infinity, so that, or negative infinity, so that's important to us. So these are special cases. Okay, so we have those very special cases. Okay, anyway, so, and you always have your graphing tool to help no matter what. Okay, so what we've got is our picture here, and it looks like just an X. And let me zoom out. Okay, because all I want to do is look at far right and far left. Well, as I scroll right, it looks like it's 0.2 as our y coordinate. And then as I scroll left, it also looks like it's 0.2. Okay, so it looks like it's pretty much 0.2. Well, 1/5 is the same as 0.2. Notice eventually in the middle here, something weird is happening, but we don't care about what's happening here. Okay, so this is more useful if our limit goes to x values that are closer to 0. Okay, so all I care about is to the right, which is 0.2. Okay, so that's it. So to the right, to the infinity is that 1/5, which again is the same as 0.2. All right, so let's check out these. All right, so if I'm going to break down this problem using those rules, I can see, hey, this is degree 7. That's the biggest power. This is degree 5. So my top is a bigger degree. Bigger degree in numerator. So by rule, that means there is no horizontal asymptote. Asymptote. So that's our rule 3 here. So the larger degree up top means we have no horizontal asymptote. However, we should still be able to get an answer to our limit. And then again, that's where I'd say, hey, well, calculator is very helpful here. So these, I'm just going to plug in again. So I have 2x to the 7 minus 15 over 4x to the 5th plus 9. Okay, and so I want to see it as it goes to the left forever. Well, for the left forever, it looks like it's going up. Looks like it's going up forever. Okay, so it looks like it's positive infinity. If our graph is kind of weird and maybe we don't trust it, here's where taking this star note could kind of help. So we could say, hey, how about we just divide those leading terms? So this is the same as 2x to the 7 over 4x to the 5th. And then we could simplify. So we've got the limit as x goes to negative infinity. X to the 7 and x to the 5th reduces to x squared because our powers subtract. 7 minus 5 is 2. 2 divided by 4 would put a 2 in the denominator. And then, well, if I plug negative infinity in now, negative squared is positive, and then, well, divide by 2 is still infinity. Okay, so that's what the limit was. So our calculator was trusty here. It did look like it was going up forever. It just is looking kind of a weird picture that was occurring. Okay, so anyway, so looking good. Okay, and one more. With this problem, this one, I'm going to skip the calculator. You could plug it in afterwards to really verify, but I see in my numerator I have a degree 2. In my denominator, I have a degree 4. And again, it's a special case where it's going to infinity. So if this is any other number, don't do this. So we would use one of the methods from the past, like these here or these here from previous videos. So be careful because none of these went to infinity. So we did these different. All right, so these are all the varieties. Okay, but anyway, so this is the special case where it's going to an infinity. And so degree 2 versus degree 4, since the smaller degree is up top and the bigger degree is down below. So smaller, 5 is, or 4, I don't know where I saw 5. 4 is bigger. So the bigger degree down below means that instantly this is 0. Okay, so and that means our horizontal asymptote is y equals 0. Okay, so you could plug this in. I'm going to skip that, so change them to x's, though, into the program. So if you do plug it in, make sure they're all x's in this line. Okay, but I'm going to skip that. You could verify, yes, to the far right, it's going to be heading toward y equals 0. Okay, so that's it. There's our limits that involve our variable here, the x or the t or whatever, going to infinity. So you get all sorts of different answers, numbers, infinity still, zeros. Okay, so it all depends on the scenario. Okay, anyway, so that's it. Thank you for watching. If you do have any questions, please let me know. Otherwise, I'll see you next time.